This is VU Calculus. We're doing topic 3, which is the limit definition of a derivative. And we're in the second part of this video series, and we're going to go ahead and do example 1. So, as a reminder, the limit definition of a derivative is f prime of x equals the limit as h approaches 0 of, in the numerator, f of x plus h minus f of x, and in the denominator, h. Okay, so the place that people are most likely to mess this up is when putting in f of x plus h. When you plug x plus h into a function, you need to plug in, anywhere you see an x, you plug in f of x plus h, or you plug in x plus h. So, for instance, if I had said f of 10, without thinking, we'd plug in 3 times 10 minus 8 and be fine. But if I say f of x plus h, a lot of people have trouble realizing that it's just a 3, and then in parentheses, where there was an x is now an x plus h minus that 8. Okay, so now let's walk through this limit. So my f prime of x is going to be the limit as h approaches 0 of f of x plus h, which is 3x plus h in parentheses minus 8, minus, in parentheses, 3x minus 8, because that whole quantity is my f of x all over an h. Now, technically, when you're evaluating limit, the first thing you're supposed to do is plug in and make sure that you don't get a number. But you're going to have a problem every time here because you're plugging in 0 on the bottom. So right away, you can plug in, but it's going to be a 0 over 0. So I need to distribute and clean some stuff up. So this is going to be the limit as h approaches 0. On the top, I get 3x plus 3h minus 8 minus 3x plus 8 all over h. So what I want you to notice is that anybody on the top that doesn't have an h magically sums to 0. The 3x and the negative 3x will sum to 0. The negative 8 and the positive 8 will sum to 0. So what ends up happening is I get that this is the limit as h approaches 0 of a 3h on top of h, which means I can cancel that h factor, so I get that this is the limit as h approaches 0 of just the number 3. Since there's nowhere to plug in h, my answer is just 3. So f prime of x is 3. That's the slope of the tangent line to this curve. Now that makes a ton of sense if you go back and look at the actual problem. F of x equals 3x minus 8. That's linear. You could tell me the slope of this without doing any math at all. The slope of this thing is 3. So it's not an accident that we end up getting a derivative, which is the same as the slope at any point x, that is 3. So that's our example 1. All right, let's do example 2. Sorry, there's an eraser somewhere, I swear. Okay, so example 2, same concept, different function. So in example 2, our function f of x is going to be x squared minus 5x plus 7. So now I'm going to have to be really careful when I do my x plus h, because anywhere there's an x, I'm going to have to plug in an x plus h. So my f prime of x is going to be the limit as h approaches 0. All right, let's go ahead and do f of x plus h in red, just so you can see what it looks like. And I'll go ahead and put this over h on the bottom. Okay, so my f of x plus h means that anywhere I see an x here, I replace it with an x plus h. So this will be x plus h quantity squared minus a 5 times an x plus h plus a 7. So this right here, this is my f of x plus h. And then in green, I'll do my minus f of x, so minus, in parentheses, x squared minus 5x plus 7, right? And all of that is over this h, right? So, same game. I could technically plug in my values now, but I know that I'm going to have a 0 on the bottom, and that I'm going to have to simplify this, so let's just go for it. Okay, so it is worth knowing how to FOIL x plus h quantity squared. It comes up often enough that it's worth knowing how to do it. But if you need to FOIL out x plus h times x plus h, you can, right? It would be x squared. The outer and inner will both be an x times h, so I'll do 2hx or 2xh, doesn't matter. And my last term will be an x squared. Or, sorry, an h squared, rather. So I get, in red, x squared. And I am going to have to write limit, but I'm going to switch back in a sec to the color that I've been writing that in. So x squared plus 2hx plus h squared. When I distribute this negative 5, I'm going to get a minus 5x and a minus 5h, and I have a plus 7. In green, when I distribute the negative, I'm going to get a negative x squared, a plus 5x, and a minus 7. Okay, all of that's going to be over an h, and I do need to write limit. I just wanted to wait until I got back to the marker that I'd been using for that. So limit as h approaches 0, okay? So now the same cool convenient thing is going to happen where anybody that doesn't have an h is magically going to sum to 0. I have an x squared and a negative x squared. I have a negative 5x and a positive 5x. I have a positive 7 and a negative 7. All of those are the things that don't have h's, and they all magically sum to 0. So what I end up with is that my f prime of x is the limit as h approaches 0 of 2hx plus h squared minus 5h all over an h. Well, I want to be able to cancel an h, so I'm going to factor one of them out. This is going to be the limit as h approaches 0 of, yank out an h, and you get 2x plus h minus 5 all over an h. I can now cancel my h. Now I'm clear to plug in, so my f prime of x is going to be 2x plus 0 minus 5. My final answer is that f prime of x is 2x minus 5. And you're going to learn a much faster way to find these derivatives in another topic day when we do the power rule and some other sum and difference rules. But for right now, we're doing these the long way, which is not something you're going to have to do for a very long time in calc, but it's good that you understand at least the concept of how to do it. All right, cool. Let's see. We'll call it there, and we'll start example 3 in the next video.